Hello everyone and welcome to another video of Vivek Learns. So in the last video we had solved a problem where we find the power of a number. So we have a number x and we also have a power n. So we have to find x raised to power n. So we found that using two approaches. The first approach, which was in the power class, was using O of n, and the next optimized approach we found was using this optimized power class where we had set the expectations that we already know x to the power n by 2, and then we found the base case and we improvised accordingly, right? So now let's continue this recursion series by solving the next problem. So this next problem is print zigzag. So what I want to do with this problem is I want to explain how the solution of this problem is. So let's say we already have the solution for this problem. So this is the solution, right? So we'll be analyzing this solution in this video. So we'll have this solution here. Okay, we copy it here. And what I want to do is that I want to analyze this solution. Do I take it? Yeah, so we have this function. Let's number the lines of this function or the method. So let's say this is line number 1, this is line number 2, this is line number 3, this is line number 4, and this is line 5. Like this system.out.println is line 5. So what will we be doing is we'll be creating a stack frame, the whole stack, and then we'll be creating stack frames in that stack. So this is the stack. Let's consider that, and now I'm creating stack frames in that. Let's create one more frame and I think this will be enough, right? So now we'll be testing this pzz function for n is equals to 2. So let me have that function called here, pzz of 2. So what happens is when the first line of this function gets executed, what will happen? It will print n. So what is n here? N is 2 here. So let's try to print the output here. So n is 2 here, so we'll print 2, right? Okay, so what we can do is that we can have all these stack frames somewhere and we can analyze those later, right? Let me copy this stack frame and have it pasted in Word. So we have this here. We minimize it. Yep, and then we can execute the second line. What does the second line do? It creates another stack frame. So what it does is pzz of n minus 1. 2 minus 1 is 1. So what will it do? It will create another stack frame. So let me select this, copy it, paste it, minimize it, minimize a bit more. Yes. Now that the second frame is created, let's try to execute the lines in those frames. So when the first line in this frame is executed, what happens is this line will get executed, system.out.print n. So n is 1 here, so 1 gets printed, right? So we'll try to do this, copy it, paste it here and minimize it. Now what does the next thing that happens is the second line of this function bzz1 gets executed. So the second line of this function gets executed, and what does that do? So it will create another stack frame which is nothing but pzz of 0. Okay, so what we can do is we can have this selected, copy it, paste it again here and minimize it. Mm, can have it pasted here. Yeah, so this is how the flow will go, right? Now that the base case is hit, like n is equals to 0, then we return. So when we return, like we don't have any line number for this base case. So let's say this is base case, right? This is B for the base case. What happens is the stack is erased at this point. So how we can represent that? We can represent that using a more thicker color like this. And let's say this is deleted. Or how can we say that? Let's have a different color or a spray. So let's say this tag frame is erased now, and we'll remove it, right? In the third one, like in the next steps, we'll remove this. So what happens is the base case is hit. So we copy it. What did I do? So I copy it, then I paste it here. So this is the next line which gets executed. Like this stack frame is deleted now because it is returned. So let's remove that from here as well. So this stack frame is removed. Now the function comes back here again and the third line gets executed. So what happens when the third line is executed? So let me have the normal brush here. So what happens when the third line is executed? We again print n, and what is n here? 1. So we'll print 1 here, right? So let me copy this. Like now I think I should have copied this, the outputs also, but never mind. Right, the third line is executed. And now that the third line is executed, we go to the fourth line. And what does the fourth line do? The fourth line, it makes another function call pzz of n minus 1. So we have another function called pzz of n minus 1, which is pzz of 0. What is pzz of 0? It is nothing but the base case, right? So let me have this. So for a moment we went down the stack frame, but now we are again going up the stack frame. So let's see. Yep. So what happens now is we have moved from here to again here, and now the fourth line is executed. A new stack trace is formed, and we have hit the base case. So let me denote this as the base case and return from here. So I'll return from here by deleting this. Let me do it in a proper way, right? So we select this, copy it, again we can paste it. So that is how we are traversing now. We'll again go down the stack. So we have hit the base case and this stack frame will be erased, right? So what what happens now if the fourth line is executed, and now we'll be heading back to the fifth line. And what is the fifth line? Oops, my bad. We have to the fifth line, and the fifth line is printing n, so it's printing 1 again. So all the lines of the stack are executed, and now we can return from the stack. So let me copy this. Yes, now we have hit the stack frame and like the last statement of the stack, and now we can return. So we can return using this. We erase this, right? So can have this shown as one more step. So this will come from this to this and the stack frame is erased. So let me erase it. So this will be erased. Let me erase the stack frame. So this is the condition which will be present after the stack frame is removed. So after that we'll execute the third line of this. So the third line of the stack executes and what we have is this system.out.println. So we'll print 2 again, right? So the 2 gets printed. Let me copy this and have it pasted here. Minimize the size a bit. Yep. So the third line gets executed and 3 is printed. Now the fourth line will be executed. And what does the fourth line do? It creates a new stack frame. So what happens is PZZ of 2 will be PZZ of 1 will be created like stack trace. Once this happens, copy this and we'll paste it in Word. Yes. So after this happens, but I haven't. Okay, let me. Yeah. So this is where we are now, right? Yep. So what's happening here? So once the fourth line gets executed, a new stack frame is created and it will again start from line 1. So first line gets executed and we print system.out.println. So we print 1. So we copy this, paste it. We also have some print. Okay, let's maximize this a bit. So once we execute the whole part, we'll see the whole picture. How is it formed and how is it not? So execute this. 1 is printed. Let's do the next part. Once 1 is printed for the second line, what happens is pzz of n minus 1 is called. So pzz of 0 is called with a new stack frame. So what does this do? What this does is it creates another stack frame, right? And we hit the base case here. So we copy it, we paste it, minimize it. So again, what we are doing is that we are moving out, like we are climbing up the stack. So once this is done, we hit the base case for n is equals to 0, we hit the base case, right? Base case. And once we hit the base case, we can remove this stack, right? So we remove this stack, correct? So I had used this one, right? We remove the stack, we select it, we copy it, we paste it again. Right, so the stack will be removed now. So let's remove this from our diagram as well. So once the stack is removed, the third line will get executed. And what does the third line do? It prints n. So what is n here? N is 1 here. So ideally we should have these inputs printed as well. Never mind. So this get executed, like the third line gets executed. And now what happens is for the fourth line, another stack frame will be created with pzz of n minus 1, which is pzz of 0. So what this does is it will create another base case. It will hit another base case for n is equals to 0. So for n is equals to 0, the base case is hit, right? So how do we represent that? We represent it using this, right? The base case. And we can delete that base frame case as well. So we delete that. Copy it, we paste it here. Minimize it as well. Right. So once the base case is completed, this stack is deleted, and now line 5 is executed. So once line 5 is executed, what happens is this line is executed, so we'll print 1 again. So we print 1, and then we have to take this for analysis mode. Paste it here. And now all the lines of this method are executed for this stack frame. So what happens is this stack frame will be removed. So how do we remove it? We remove it by erasing it. Let me erase this. And now that the stack frame is erased, we'll execute line 5. So once line 5 is executed, the n is printed, not 1. This line is executed and we print 2 again. So that is how the things work for this PZZ problem. So let's analyze this first. Let's check the output that we have. Is it the same? So the output that we have is 2 1 1 1 2 1 1 1 2 2 triple 1 2 triple 1 2. So let's check if that was the output. Yes, for n is equals to 2, we had 2 triple 1 2 2 triple 1 2. So how did we get that? Let's analyze that in the word, right? So what we are doing here is, let's have a minor view here. So when the first line gets executed, we print something and then we traverse up the stack. And when we hit the base case, we are traversing down the stack. And then again we are traversing up the stack and then we are traversing down the stack. And then again we are traversing up, right up here. And then we are traversing down again from here, from here. And then we finally have the stack as empty. So one observation we can do from here is that if we have any one particular function, like only if we had pzz of n minus 1, so whatever the lines that are above this method, they will be executed when we are moving up the stack. And whatever lines are present below this function, they will be executed when moving down, right? So this is one observation that we have. So when we traverse up the stack, like if we start from, we are going from 2 to 1 to 0. So only these lines will be printed. And if we, whenever we are coming down from the stack, then these lines will be printed. Like suppose this function is not, like this part is not present for now, only this 1 to 3 lines are present. So system.out.print n will be printed when we are traversing up, and the one below that will be printed when we are traversing down. So that is one observation that we have. But what is this? Like how do we analyze this? So to analyze, there's two calls. Let me take that once more and let me tell you how I'll classify those. So have those, we have two recursive calls here, right? Two method calls here basically. We have it up here. Yep. So what we call this is, we call this as something, we call this as something, we call this as something. Similarly, all the areas will be naming something, right? So what do we call this function? So we'll call this function as left call. What will we call this function? Let's say this function is right call. And the area between the left and the right call is the in area. Right? And the area before the left call is pre-area, let's say. And the area post the area before the left call is pre-area, and the area post the right call is post area. So that is how we will be defining these areas, correct? And this is the base case, so we won't consider this in any part of the area, right? So how do we simplify this and have this in the more easy manner? How do we solve this problem in a more easy manner? So what we can do is that we can create a Euler's diagram for this. We can create a Euler's path for this and we can analyze that. So let me have this up here and we can draw the Euler's diagram now. So to draw the Euler's diagram, let me get rid of this as well. So we have two first, right? Then we branch from here. Okay. Then we branch again from here. So this is the Euler's diagram. So this is for n equals 2. So similarly we can have it for n is equals to 4 or something like that. And how do we get this output from the Euler's diagram now? So the area to the left is called pre-area. The area between left and right is called in. This is the in area. This is the pre-area. This is the in area and this is the right area or the post area that we have for any of the number. So let's start with the analysis. So for the first line, when the first line gets executed, what happens is we are in the pre-area. So what gets printed? We print pre1, let's say. So instead of printing, pre2, sorry, not pre1, we print pre2. So instead of just printing the numbers, we are appending pre, post, and in to this, right? We are prefixing, not appending. So we print pre2 because we are on the left side. Once we traverse, once we are done with that, when we execute the second line, we are traversing up the stack and we are also traversing up the Euler's path. And now the stack will contain 2 as well as 1, right? So when the first line of this stack gets executed, we'll print n. So this is to the left of 1, right? So what gets printed? It prints pre1. Pre1 is printed. And when the second line of this statement executes, we are here again. So this is the base case. We don't do anything for the base case. Then we come again, we return. So when we are here, like when we are on this, well, this line, so we go up, that is we are executing the third. Um, when we are executing the second line, we go up the stack, and when the base case is hit, we are traversing down the stack, and then we execute the third line. So what does the third line print? The third line will print in 1, in 1. And what does the fourth line do? The fourth line again will go up the stack, will hit the base case and come back again. And when coming back, we execute the fifth line. So what does the fifth line do? The fifth line prints n. N is 1 here. So we are printing post 1 because we are to the right side of 1. Post 1, right? And then we come again down here, and then we come to this. What happens now is that two lines of this function are executed. Now we'll be executing the third line. So what does the third line do? So the third line prints n, which is printing 2, but now we'll be printing in because we are in the middle of the left and the right column, right? So we'll be printing 2 here. And similarly, we'll traverse up now for the fourth line. When we execute the fourth line, we'll traverse up. Then we have this function call. So for the first line of this function call, pre1 is printed because the Euler's path is to the left. So pre1 is printed. Pre1, let's say. And then once pre1 is printed and we execute second line, we traverse up the stack, we hit the base case, and for the third line which is executed, we come here, and this is the in part, like this area that we are talking about. So what do we print here? For the third line which gets executed, we'll print in 1 because we print n here. So this is the third line which gets executed, right? And then what happens is for the fourth line, we again traverse up the stack, right? We again traverse up, we hit the base case, and we come down again, right? Once we hit the base case, we come down again. We come here. So the fifth line gets executed here, and then we print post 1, right? Once we print post 1, all the lines of this stack frame are completed, and then we come down again here, and the fifth line of this last stack will be printed, like of PZZ2 stack will be printed, and then we'll execute the last statement, like the fifth statement, which is post 2. So this is how we can analyze any problem. Like we can have that pre area, left call, in area, right call, post area. So whenever we see any function with multiple calls, we can draw an Euler's diagram and we can analyze using the Euler's path in such a manner. So that was all for this video. Thank you. See you guys in the next one.